welcome back everyone. It's time to start digging into the underside of the Philco Predicta holiday here. And I've been eyeballing the work that has been done and the work that needs to be done, which is all of it really. And taking a look, and I finally found a copy of the Sam's Photo Fact for this. I'd misplaced it on the internet. And I need to start going through and checking the values of all of these Black Beauty capacitors that are poking around, as well as the ones that have been replaced with orange drops, and verifying these are correct. And I'm replacing them anyway simply because the attachment in most cases is pretty poor, and I just prefer knowing that I have the correct ones in there and that the connections are done nicely. I also need to take a look at what's going on with all these power resistors right here, because this just screams screwy. And there's also an inductor down here that looks like it's received some heat damage, possibly from ham-fisted use of a soldering iron. Not too sure. And then, of course, the joy that is replacing these 3 multi-section electrolytics. However, I'm going to be doing this in stages instead of just trying to do the whole thing in one go. I do it kind of slowly. I think what I'm going to focus on is most of the paper caps that are over in this region, get those worked out, then hook it back up to the CRT, see what we get, and then I got to deal with ordering parts for this, because this can right here contains a number of values that I simply do not have. Let me see if I can read it here. We have a 140 microfarad at 300 volts, 100 microfarads at 300 volts, and then a pair of 20s at 300 volts. I don't think I have anything near 100 at a rating like that. I don't think, at least. No, probably not. The other thing is, those are going to be fairly large, and the wiring going to this can is somewhat short, and it's wrapped around the chassis. I do intend to put a terminal strip over here to mount everything to. What I'll probably wind up having to do is add wire extensions to the connections that are here. I did also consider using one of the adapter caps and seeing if I couldn't mount it horizontally, but I don't think I'm going to be able to do that. Again, have to look and see what kind of capacitors I can order to do that with. Same thing for this guy, I'm not sure, probably just try to mount a terminal post or something. There's plenty of holes nearby that I could attach it to. And then same thing with this one. That's later, so I'm going to focus on working around in this area and avoiding the power supply components. In fact, for now, to keep this from flopping around, I'm just going to stick the clamp that was holding it in place back onto the chassis so that it won't move around. Actually, no, we don't really need to do that. It's alright. But yeah, I'm going to focus down here, go through here. We do have this one couplet, which I have a replacement for. And yeah, that about does it. I also need to go through here with the air compressor and blow out all the dust. There's quite a bit of dust on things. Oh, one neat little thing that I did find is, so here's the socket at the bottom of the 1B3 high voltage rectifier. These are the filament wires coming off here, and I was expecting that the flyback transformer would have an extra winding on it like it normally does for the filament, just coming out of the wax. That was not the case on this guy. Instead, this wire just goes through this hole in the chassis and does a half turn around the bottom of the laminations for that transformer, and then it's held in place with a metal clip to sort of pinch the wires together in a horseshoe shape. And that's it. That's all the magnetic coupling that the transformer has to this piece of wire to get the 1 volt needed to run that filament, which I thought was kind of neat. Oh, also, this goofy disc over here that I spaced on in my first video, this is the filament slow start resistor. So this disc apparently gets broken a lot. Mine is functional. That's the guy that we're going to be replacing with a pair of these inrush current limiters. This is the particular part that Bob Anderson spec'd, because a pair of these in series gives a much better approximate cold resistance on startup than a single, what is it, CL90, I think, is typically what you wind up using for a lot of other radio work. The CL90 has too low of a cold resistance for this set. You'd actually be giving it more inrush current on startup than you want. So a pair of these little guys is apparently where you want to be. Yeah, so these are 220 ohms each cold, if the data sheet's to be believed. So that should do it for this. And yeah, get that replaced. This one's working for right now, so I'm not going to mess with it immediately. We've also got a disc capacitor here that's rated at 5 kilovolts, which is interesting. It's probably still okay, and then we'll leave it alone. And then, of course, there's a number of resistors under here we'll take a look at and see how they're doing. But yeah, I'll catch back up to you once I've gotten some more progress on the side here. Alrighty, work done thus far. I've covered all of the paper caps down here. New couplet is installed. I did replace one resistor simply because in the process of moving some things around I broke off one of the leads. It's still measured in spec. And anywhere I'm attacking a capacitor, if there's a resistor also on the same lead, double check the resistance via the schematic. I did leave in one of the orange drops, this I think it's a 0.047 right here, because the closest value I had was like a 0.05, and it meets the specs and it's not really hurting anything, so I figured I'd leave that one alone. I did replace the other ones just because the installation wasn't done very cleanly, and because moving it allowed me to get to other things. The SAMs for this is actually kind of not that great, especially in this area right here. I think there were some changes made because the SAMs does not seem to include this terminal strip right here. It was a little confusing because the arrows point to capacitors. There's one great big capacitor that sits right about here, and there's some other stuff trapped around it. And the SAMs alludes that it's there with the arrows, but doesn't actually show you that there's other stuff under there. You kind of have to guess and check for the schematic. One thing that I did find, though, this I think it was this one that was here. Yeah, it was in here. One end ties to ground, the other end ties to this lug. This lug right here. I had to double check. This is actually one of the connections from the power supply socket. This quite literally just loops back and around into this post and then heads off to the power switch. The other leg of this went to ground. This is actually the cross-the-line safety capacitor. So that's been replaced with an X-type within the right ratings. And there were two other caps here that share a common connection to the 280 volt bus, one of which is a 0.1 and the other was a, sorry, I think it was that guy right there that was a 0.01. I can't remember exactly. One of those is for the local distance switch on the back wafer here for the VHF, UHF terminals. Got that swapped out. And then a few other guys up here. One of these up here, actually, I'm sorry for just pointing out, this was this one right here. This is supposed to be a 0.15. I don't stock 0.15s. It's not really a common value you buy anymore. 0.22 and 0.1 are the closest to that, and I guess a 0.1 would have been closer, but yeah. I looked at that part of the circuit, and it's not used for timing or anything, so I think it should be fine. The other one below it, this guy right here, was actually a 0.22, so swap that in. And there was another 0.22, this guy, right here in front of the couplet. And that about covers it for that half of the chassis. I've bolted this electrolytic back down, and we're going to go pop it back in the unit and see if we get any slightly different results, or if we get nothing. Okay. It looks like we've eliminated... Nope, there it is. Whatever that shit's about. Okay, if I bring the voltage up a little more. Seems to stabilize once it's at full line voltage. Okay. Well, we're at about 105 volts on the Variac. And we have a raster that fills the screen and appears to be stable. And there's no smoke coming out of anything. And there's no arcing from the flyback, so I'd say that's pretty good. That's 110 volts. Alright. Let's see if I can't quickly get a picture before something decides to go wrong. There we are. Alright. That's all the proof I need. Perfect. Okay, and that does also confirm the connections of the speaker. I couldn't quite find any references to tell me which pins on the board were supposed to be for the speaker connections. I had to trace back through the schematic. I'll show you what I mean in just a second here. Okay, so here on the side of the board, this guy over here is our cathode connection for the picture tube for the video signal. And then over here, we have a green wire and a black wire. Now, the schematic, the SAMs anyway, does not do a fantastic job of noting this. The green wire here actually wraps underneath the chassis, and halfway across is spliced into a blue wire with a piece of friction tape around it. That blue wire comes out over here. Let me get my screwdriver, and attaches to this post next to this 12CA, is that 12CA5? This is our audio output tube, and that wire right there is coming off the plate of the 12CA5. That wraps around and comes to this post, the green wire here, and that's one half of the connection goes out because the audio transformer lives on the speaker, on the back of it. This black wire here, though, based on the schematic, this is actually the 280 volt connection tie point. Now the schematic says it's red wire. Well, yes, the feeder wire for it is red, but the wire going up to here is black. So these two right here are your speaker connection. One line for the plate voltage going in through the transformer primary, coming back through the green, which becomes the blue, and then going into the plate at the 12CA5. I wasn't quite sure if I'd attached these to the wrong posts or not, but because I heard hum coming out of the speaker, I know we've got it where it needs to be. And yeah, so it's also nice to confirm that the glitchiness in the horizontal is purely a result of the line voltage being too low. Once I brought it up to about where it would be for normally operating, it stabilized and that obnoxious noise mostly went away. I'm sure with a little more work on the electrolytics and everything, and then of course probably adjusting it on the driver board here, it probably should be a lot better. But I'm going to unhook all this junk and we'll flip it back over, and I'm going to need to put a parts list together because I need to start ordering all the electrolytics for replacement in this guy. Alright, my Mauser order showed up. I managed to get the remaining capacitors knocked out. These were not particularly cheap. Most notably, the 140 microfarad cap that goes up here. It's rated at 300 volts. Closest standard value I decided to go with was a 450 at 150 microfarads. I only wound up buying two of those because they're like $5 a pop, and shipping through Mauser is already kind of expensive. I think an order of 3 capacitors, 3 different SKUs anyway, was at least $40 with the shipping. So I didn't get as many as I wanted to, but I did pick up at least 5 or more of the smaller ones, depending on if they've got a good price break. And if they're really cheap, I at least buy 10. Like these 50 volt 220 microfarad, I think I probably got 20 of those. So they were fairly cheap. But some values that I know I wind up using more than once on other projects, I'll try to get multiples of. But really weird stuff, if it's pricey, I might just buy 1 or 2 of the backup. Anyway, that being said, yeah, I got all the electrolytics replaced over here. This one primary can that would have sat right there. I installed the terminal strip, I actually drilled the chassis for it and installed pop rivets. If I were to do that again, I would use self-tapping sheet metal screws. I didn't have any that were short enough, though. The distance between the PCB here and the top of the chassis did not allow any of the screws that I had on hand. They would have started touching the traces. These pop rivets, when they're compressed, are short enough to miss it. So that was good. And I'll probably wind up doing a similar setup here with the last 3 section in here. This is the last electrolytic I have to deal with. There's this 4 section. So I got the 222s, or the 20 microfarad, 400 whatever volt, and there's a 100 microfarad, and there's supposed to be a 140, so I use 22 as a 120 and a 140. And these are all 105 degrees Celsius rated caps, so they can deal with the heat. And just for the heck of it, I also used magic marker and put the appropriate can symbol next to each one, so the half moon, the square, and the triangle. Now the cap that lives up here, the insulated cardboard guy, is a single section. It's actually kind of crushed when it was installed. This is the original Philco sleeve. I'm going to hang on to that. 140 microfarads, 150 working volts. This cap is actually part of the main part of the high voltage power supply. It's part of a voltage doubler assembly. The diodes for which are on the top side of the chassis. This one's had 2 new silicon diodes installed. It's a little sloppy, but it works. And that plugs into there with this yellow wire. Now there's a cap coming off of it right here, and I've already replaced it, but I'm going to have to undo that because, and unfortunately I don't have a paper copy of the schematic. None of my printers work. This cap right here is actually coming off of one side of the power line. So the negative lead here is actually connected through, and it's connected through the fusible resistor on the other side here, the sand resistor. That comes up through there. And the other lead that comes off of that thing is right here, and that couples back. It's kind of a mess, but either way, this capacitor is connected through to the power socket, and this particular cap right here happens to bridge both the hot and neutral connections. So I'm I'm going to wind up replacing that guy with an appropriate X1Y2 capacitor. These are the only ones I have in a value this small. I can't remember exactly what it was. Probably like a 0.001 or a 0001. Fairly small, but it was in a spot that I realized a normal film cap would probably not. If it failed, it would cause a dead short across the power supply and it would probably explode. So I'm going to swap that out later on. With it on the Variac, I'm not too worried with the isolation transformer bringing it up slowly. But when I replace this guy and start tackling the other half of the chassis, that's got to go. Just for my own peace of mind. In the meantime, I'm going to get this hooked back up to the CRT and see if everything is still alright. I know it seems a little bit redundant, but having never serviced one of these chassis before, I'm trying to be careful with it because I want to make sure I do a good job on my Siesta. Okay, that was less good. Yeah, I honestly don't know what the heck that was about. That went not as good as I was hoping, honestly. So we got pulsing in the audio circuit, and the flyback circuit is rather unhappy, and now our raster is shoved far over to the right side of the CRT. Interesting. And realistically, all I did was change out the one multi-section electrolytic. Not really sure if I press onward and keep replacing the other few electrolytics, or if I try chasing through the circuit to find out if there's something else wrong that I touched earlier. I honestly don't know. Because it sounds like the horizontal oscillator is not running at the correct frequency. It shouldn't be that obnoxious. It should be, you should be able to hear it, but it should be distant in the background. Very, yeah. Well, I'll have to deal with this later because something else has come up that I need to work on in the meantime. So I'm kind of going to have to put the Philco here aside for a bit, work on the other thing, and then I can come back to this. I don't really have a deadline set for it. It's just something I wanted to mess with. So I hate to stall on it, but I actually have paying work that I need to get into that is a little more time sensitive. So for right now, thanks for sticking along with me, and I promise I will get back to this as soon as the other project is dealt with. I don't know how long it'll take. I'm going to tear into it here soon, but yeah, thanks for watching, and hopefully when I get in here next, I'll have some idea of what is going on with this thing.